Now coming to the preparations of alkynes. See, when calcium carbide, look at calcium carbide is hydrolyzed. See, for convenience, let me write it this way. Calcium carbide is an interesting compound. Now, within calcium carbide, generally they'll be asking the number of sigma and pi bonds between the two carbon atoms, 1 sigma and 2 pi, right? Now, when calcium carbide is subjected to hydrolysis, look at what happens. HC triple bond CH. Along with that, you get calcium hydroxide. Okay. Now, acetylene, then calcium hydroxide. You know, I have an interesting point here that this acetylene has garlic odor. Okay. So this garlic odor is due to impurities like phosphine and hydrogen sulfide. Okay. So that is a preparation of acetylene from calcium carbide by hydrolysis. Now there is another carbide which we come across most frequently. Let me also give that. Magnesium carbide. So this magnesium carbide on hydrolysis gives propyne. Okay. We have already come across two more carbides. One is aluminum carbide and the other one is beryllium carbide, which on hydrolysis gave methane, right? Hope you remember. Now here you get magnesium hydroxide. 2 magnesium coming to oxygens, we got 4. So write 4. That's it. Okay. Now the second preparation method is the one that we have already come across in the preparations of alkanes as well as alkenes. Let us see. See, this is of course malic acid, right? This is malic acid, a cis compound. butadiene dioic acid is malic acid. Right? Now, if you consider the trans form of that, it is called fumaric acid. Okay. Cis and trans. Okay. Now let us consider the sodium salts of these acids. You can go with sodium maleate or even sodium fumarate also. Okay. So let us consider sodium. Yes, this is sodium maleate. Aqueous solution of this on electrolysis. Okay. What happens? You all know the mechanism properly. Only for convenience sake, let me take this way. But in general, we go with the free radical mechanism. Come on, you can take this thing from where you get your acetylene, carbon dioxide. Now these two are formed at cathode. Acetylene and carbon dioxide are formed at anode. Then, yes, sodium hydroxide and hydrogen. These are formed at acetylene and carbon dioxide at anode, sodium hydroxide and hydrogen are formed at cathode. Okay. So this is coal base electrolysis. Look at malic acid. Hope you remember two more things. Let me also give you those two interesting names. One is malonic acid. Told you this when we discussed oh my such good apples. So this is malonic. Like there is one more thing called malic acid. Malic. Malic. Say this. Malic. Malic. See, the source of this malic acid is Pyrus malus. Pyrus malus is apple. So, see, this is actually a derivative of succinic acid. I can say alpha hydroxy succinic acid. We know that this is, I mean, butane dioic acid is succinic acid. but a hydrogenate alpha carbon is replaced by hydroxy. So this is Malic. See the difference? Malic, Malic, melonic, right? Okay. Now let us take dehalogenation. Dehalogenation followed by coupling of the trihalogen derivative. Okay. See, this is a trihalogen derivative. On distillation using silver powder, taking it this way for convenience. Okay. On distillation, look at. Yeah, we have 6 halogens, so let me take 6 silver atoms. Now all 6 silver halides are removed. R, C, triple bond, CR. Okay, what has happened? Now right from this to this, everything has been eliminated. So these two got connected by triple bond. Now 6 moles of silver halide. Okay. Let us take an example. A regular preparation method of acetylene, the basic one. You know, chloroform on distillation with silver powder. Chloroform on distillation with silver powder gives acetylene. Plus 6 kgCl. Okay, so this is dehalogenation. D means removal. You have removed the halogen atoms using silver powder. Berthelot's synthesis used this in the preparation of methane. Now again the same kind of thing. See, when an electric arc is struck between carbon electrodes in an atmosphere of hydrogen, we get acetylene. Same thing as what we did in the preparation of alkynes. I mean, in the preparation of methane. Even from natural gas also, we can prepare acetylene. See, natural gas is rich in methane. I mean, the major constituent of natural gas is methane. When this methane is heated for a very short time, say about 0.01 seconds, very short time, at about 1500 degrees centigrade, nothing but pyrolysis. You are heating it to very high temperature, upon which we get acetylene and hydrogen. Got 8 hydrogens here, so 2 plus, make it 3. Okay, so this is how we can prepare acetylene from natural gas. Then let us go for dehydro halogenation. Nothing but the removal of hydrogen and halogen atoms. Let us consider two things: vicinal dihalides, geminal dihalides. So this is a kind of elimination. So this is vicinal dihalide. When halogen atoms are on adjacent carbon, it is said to be a vicinal dihalide. Now, using a base, we'll discuss about the different types of bases used later. But for now, see, using a base, we can abstract this H plus. As and when this goes off, this one comes here, and this, along with the bonded pair, goes off. Look at what happens. So we have eliminated HX. This happens very fast. I'll tell you the reasons. R dash, then the thing that is left is X. Yes, now we got a vinyl halide, right? Now this again undergoes dehydrohalogenation, elimination of HX again. But interesting is this is slow. First step is fast, second step is slow. Even here also, base abstracts H plus, this will come here, then this goes off. That's it. We get alkyne. So this is how the vicinal dihalide undergoes dehydrohalogenation. Hope this is clear. So let us also consider a geminal dihalide, almost similar. Geminal is the one that has two halogen atoms on the same carbon. Geminous means a twin. This is geminal. You got both the halogen atoms on the same carbon, right? Now, using the base, let us first subtract a hydrogen in the form of H plus. Say H plus is abstracted. This comes here, this one goes up. We get H, C, then R, here a double bond, then C, R dash, X. Again, a vinyl halide is what we call.